Okay, error number 1 is right here. There's the first error from this step to the next step. So I'm going to fix it on the right side. I get 3. Now, instead of writing 9, I'm going to write 3 squared. And what I get on the next line is 4x plus 2. That is the correction. Okay, mistake number 1. Let's see if we can find mistake number 2. Anyone find mistake number 2?
Yeah.
Yeah, where'd you get it?
So, when you're simplifying 1/9 to like the 1/2 x power, they forgot to x.
Okay, yeah, it's right in here. The x is forgotten, but there is another mistake.
There needs to be a negative, like negative. It would turn to negative 1/2.
So there's a negative missing. Now, you could have fixed this 2 ways. Okay, so let's do one way. How many of you thought square root up here? Yeah? Okay, so I'm going to fix it 2 ways. I'm going to take the 1/9 and I'm going to write that as a 3 to the negative 2. Okay, look at how I fixed it. I saw 1/9 as 3 to the negative 2. Notice that the only thing I'm changing right now is the quantity that's inside the parentheses. I'm just rewriting the base, okay, using powers, just like Unit 5, okay? And then to fix the next line, I'm going to multiply, and I'm going to get negative x. And so the mistake here was kind of doing powers and roots backwards. I was thinking square root, but I used a 1/2 power, or I was thinking squared, and I was just backwards, right? I meant times 2, not times 1/2, and then I forgot the x. Okay, then comes the implication, and my implication was actually correct based on what was done. And so this step was okay. This was okay. Where's my next mistake? Where?
When you do the dividing, you're supposed to divide.
Yeah, times by 4 instead of divided by 4. Okay, now I'm going to fix the rest of the work here. The implication, I'm going to do one more step. 1 plus 4x plus 2. Because really, I add exponents when I multiply the same base, which means 1 plus 4x plus 2 equals negative x.
So 4x plus 3 equals negative x?
Yes. Or 5x equals negative 3. So x equals negative 3/5. That's the correct answer. But guys, I made 3 very common mistakes. So be careful with your work. Make sure you know exactly what you're trying to do. Yes.
So for the top, right, when you broke down 9 and you made it 3 squared to the 2x plus 1, right? Shouldn't it be 3? Why did I get 3x to the third? Or 3 to the 3x? Sorry.
Because 3 times 3 is 9. But 3 squared is 9. I think maybe you said 3 times 3, but it's 3 power 3. Gotta make sure you're doing a power.
Yeah.
Yeah. Now, I could have thought this instead. 1/9 to a 1/2, and then leave my x out here. I could have square rooted this, which is 1/3, and then I could have reciprocaled, which would have given me this. Right? There's multiple approaches to get to a place where you can actually eliminate the bases. It just depends upon what you see. Okay. You can do these on the front or the back of this sheet. I'm going to put up a couple extra problems. Let's see how fast you can solve them. Ready? Yeah, it's like scratch work, okay? There you go. Solve for x. Right, scratch work. It doesn't have to be pretty. Just find x.
Is that 3x to the second?
That is 3x to the second. 32. Two answers, one positive, one negative. I'm just timing you. I'll put the answers up. I'm going to give you a minute each. Because it's quadratic. Oh, it's plus or minus 1.
Yay!
Plus or minus 1. Okay, because, all right, look at what we're going to rewrite. 32 is 2 to the 5th. So the implication is 3x squared plus 2 equals 5. You imply something that is simpler to solve. Guys, that's a quadratic, okay? So 3x squared equals 3x squared equals 1 plus or minus 1. Right? Square root. Yes.
On the test, do we need to do a little implication arrows?
As long as I can follow your steps, that's fine. Yeah.
Wait,
Okay.
what happens if we had done it in the, we had to do it in that order, right?
No, there's a couple different ways to do it, but if you're not sure, I'll come look. All right, next. Okay, solve. I'll give you 70 seconds.
Wait, is that 3 to the x?
3 to the x squared. Jeopardy?
I love Jeopardy, but Alex Trebek has cancer now.
No, I haven't watched it. I'm so awkward.
Okay. Shh. 20 seconds.
You can still be annoying.
20 seconds.
Dang.
There are 2 answers. One positive, one negative.
So awkward. It's like,
Keep going. 2 answers. One positive, one negative.
I got it.
And the answers are 6 and negative 3. Okay. Nice job. All right. Next. Ooh, fancy. We're getting a little trickier. A little trickier. Okay, you can do it. You gotta make it b to the x equals b to the y before you're allowed to do the implication. There's more than one approach. Just pick one.
Oh, I know.
Right? There's a.
I know.
I know.
Do you really know?
I got it.
So did I. I'm not there.
I'm 30 more seconds.
I got a half.
I got it.
Exponents have to have.
I definitely want to draw. Let's go. So stop. 1 minus x.
Parentheses, exponents. Multiply by 5. You have to do exponent rules before you multiply.
How many answers are there?
1 answer and it's negative. Negative 2. Okay. Here we go. I'm going to 2 ways. I first notice that 16 is 2 to the 4th, which ends up being 2 to the 4 plus x, which ends up being 2 squared, okay? So implies these things are equal, so x is -2. But maybe I was like, there's only one x. Maybe I try to isolate, and I divide by 16 first, which is perfectly acceptable. 2 to the x equals 4 over 16, which is 1/4. 2 to the x is just -2, implies x is -2. Does it matter which way you do it? No. It doesn't. Okay, little trickier. There's only 2 more. This is it. The last one is the trickiest. Make sure that you are doing your homework. Your worksheets. There's, I don't think you're going to get homework tonight. You can do it. There is one answer, and it's positive. I'm not going to tell you, it's positive. You should be able to do it without.
Oh! Alright,
Can you, are you gonna, do this one?
You got 20 more seconds, then we'll do it.
yes. Wait, I'm doing something wrong. No.
It's one positive integer.
Wait, oh, I got it.
Josh is correct.
I mean, like, what is
Okay,
it?
so the answer is 6. Okay. Here we go. 128. Guys, there's only one x. You can try isolating it. Now, here you got 2 choices here. Maybe I see this. Oh, 128. Okay. So 128 is at least even, so I know it divides by 2. I notice 64 is 8 times 8, right? Skip to your perfect squares. Why not? Okay? But 8 is 2 cubed. That's 2 to the 7th. Why was I trying 2? Because that's the base I saw on the other side of the equation. Okay, implies I almost don't even need to write, like I can get to 6 without doing anything else. Other choice. What if you actually just divided both sides by 2 because there's like a coefficient? Oh, and then you're like, oh, well 64 is just 2 to the 6th. X is 6.
I just realized you could do that.
Yeah. Right, multiply, because I'm not touching the exponential. You can certainly divide. Yes. All right, last question. Trickiest one. Trickiest one. See what you can do. We'll go 1 minute from now. You can do it. It's negative and a fraction.
6.
Negative and a fraction.
Thanks.
So not that.
Oh. You want to bet?
Wait, so it's a fraction?
It's a negative fraction.
Wait, it's a negative number.
same mistake I made on the day.
Oh,
Because I know like it happens.
Is it a negative?
Wait, what's your multiply the negative?
Wait, negative 9 cents?
Negative 97.
Negative.
Negative 97.
Because you get a negative exponent right here.
It literally says a negative front.
I know, I understand that you were the negative. I'm just trying to think what gives you negative.
Well, when you mix powers and roots, it gets trickier to predict the answers.
If I read the negative line, like there's a negative on the big yellow stuff.
Okay, negative 9 over 7. So, whew, okay, I can start with, now, I can even try 8. Okay, I notice that 64 is a perfect square. And so I need to try 256 though. Like, does 256, is it a power of 8? And I don't think so, but I'm going to try it. So I'm going to divide by 8. Okay, so 256 is 8 times 32. That's not a power of 8. It means I need to go down in the base. I need to pick a smaller number. So let's try 4. Let's try 4. You should sort of recognize some of your perfect cubes now. Okay? And so I'm going to try dividing by 4 over here and see if it works. Okay, let's try 4. 6. Oh, okay, so this is going to work because you see how I just got 64? Which means that the right side is 4 to the 4th. 4 to the 4th. And the left side is not 4 cubed, it's 4 negative 3. Okay, that implies that negative 3x minus 9, distribute, equals 4x. Don't delete your 4, which gives you negative 9, 7x, negative 9/7. There you go. Okay, some of them use properties, some of them don't. Okay, don't forget that you can isolate things and do some operations first. Okay, make sure that you guys are working through worksheet 2 evens. You're not going to have a lot of worksheet 3 tonight. I might ask you to do like 2 or 3 questions. Okay, because we're going to do just a little bit of your next lesson. Okay? You should have a graph paper, so you can title it Lesson 2, and we'll start graphing in just a second. That's the same thing. So that's okay. No, because you distribute. Yes, but not yet. We're going to write something down first. All right, notebook. Here we go. We're going to do about a half a page. Okay. Hang on to your graph paper. We're going to write about a half a page explanation before we actually graph. Half a page. We'll see. Okay. Lesson 2.
No, it's fine.
Oh, do we even do Eric?
We actually have 2 new parents. Okay? 2 new parents. We only need quadrants 1 and 2. And we only need one set of we only need one table in the middle. We're going to get 2 shapes though. Right? We're not on the grid yet. We're going to save the actual graphs for when we put numbers up here. We're just going to sketch the basic shape. And we're going to graph y equals b to the x. Yeah, I left it as a b, just regular old b, which is some number. Probably not. They'll probably go on the next page. Okay. We're going to plug in those 5 values to the function, right, and list out the y coordinates that you would get. All right. B to the x. All right, eyes up. Here are my points. It's a little hard to graph them because I don't actually have numbers. I have b. But notice that this is exponential, means I'm writing powers of b. Powers of b. B squared, b cubed, b to the 4th, b to the 1st, b to the 0. Yes?
Why aren't you doing like b to the 3rd?
I could, but I don't need, really, we only need about 3 points to plot the correct shape. So I put a couple extras so we get more of the trend, but on your graphs, I probably only need 1 point once you get the hang of the shape. Okay, now, let's graph it. The only point I can graph is right here. 0, 1. That's the only point that actually has a number for the x and the y. And so let's put that on the graph. And we're going to start with this one where the base, I'm going to say the base is more than 1, like 2 or 3 or 4 or 3/2 or 1.1. Any number more than 1 is my next point. Okay, is this point right here, 1b, going to be higher than or lower than this one? Higher. All right. I'm not actually, notice I didn't actually label the coordinate. I just put it higher. Higher. 1b, because it's higher than the starting point of 1 because the base is bigger. Okay? Where would b squared be? Even higher. I noticed the scale, guys. I didn't actually label the y-axis any more than the 1 because that's the only point I actually know. This one is even more. Okay, now we got to go the other direction. Oh, yeah, 2. Thank you. Thank you. 2. Okay, let's go the negative x's.
It would be lower, but not separated into 0.
Second picture. Right? Different type of.
Lower.
Okay, lower. Yes. 1 over b squared. Lower.
But it doesn't touch 0.
But it doesn't touch 0. But it gets really, really close to 0. It's called an asymptote. It approaches 0. Okay, now, but notice that it's actually only approaching 0 on the left side, so I'm going to write my HA, my horizontal asymptote, on the left side of the graph as a reminder to myself that it's only happening on the left side. And then I'm going to write my end behavior statement that goes with it. X arrow negative infinity, Y arrow 0. As x approaches negative infinity, the y coordinate is also approaching 0. And this is what the graph looks like. That's it. Now I'm going to add the other end behavior statement. But as the graph goes to the right, the arrow is top right. It's quadrant 1. That's plus plus. This is the first time we've had this end behavior statement that's had a number and an infinity. But think about what happens as you actually continue on this trend of points. And behaviors are trends. It's like what's happening as x approaches negative infinity, well, y approaches 0. It doesn't touch it because I can think about the reciprocal. Doesn't touch it. Okay. Second picture. What if I tell you that the base is between 0 and 1? Okay, and then we'll write our same statements here. And I'm going to put the 0, 1 because that's the only point, right guys, the parent points, they don't change. But think about what number you're plotting. Is it going to go up higher or lower? Lower. Look at, very similar, except one gets smaller, the other one gets bigger. Oh, this has an asymptote too, but it's on the other side. So I'm going to label it on the right side of the graph, and that is only to help me know I want the graph to get closer on that side. Yes? Okay, so if, let's pick a number, say 1/2. What's b 1/2? Which means that it's going to be less than the starting point of 0, 1, because the base is going to be less than 1, which means if I'm comparing it, it's got to be less than, and then even less, and even less. And then if I do the powers, and we're going to put numbers in here so you can actually plot them. Okay, we have names for these pictures. This one is called growth. This one is called decay. It's because this one is growing and this one is not. But growth and decay, notice that the HA is 0. It is specifically these pictures. Okay, and I'm going to put a range here. The range is this. Notice that the range is the same on both of these graphs. They both are 0, positive infinity, quadrants 1 and 2. This is specific for growth and decay.
Will it always be like one side would be lower and the other side?
Yes, yes. With this exponential, the trend of points will always do this. One side will get smaller, the other side will get bigger. Yes.
Oh, okay. Is it always going to be just the first two quadrants, or is it ever going to be like?
Okay, so we're about to do A, H, and K.
Okay.
So we can shift this graph right, left, stretch, compress, and reflect. And that's what we're going to do next. Okay, I want to do 2 very quick pictures, not on your graphs yet. Okay? We're going to graph with some actual numbers so you can see what this will look like. Okay? We're going to do 1 growth and 1 decay. Y equals 2 to the x. All right, so this one I gave you, the base is more than 1, so that should be growth. And this one, I guess we could do 1/2. This one, the base, is between 0 and 1. Okay. And this time we can actually put tick marks on the graph. Okay. Three points maximum, guys. Do not draw more than 3 points on the graph. Alright. -1, 0, and 1. I like to get the center, right? 0. And I like to get a little bit to the left and a little bit to the right. One half, 1, and 2. I like to see the center, the 0, 1, and I like to see the reciprocal and the base, right? 1 over b and b. And then I plot. And then I draw my asymptote. And then I'm like, which side do I put my asymptote on? The left side or the right side? Which point has points closer to the asymptote? Then it goes on the left. Right? When you plot more than 1 point, whichever side is closer to the asymptote, that's the side that goes to the asymptote. The left side has points closer to the asymptote. That's why you want more than 1 point until you get the hang of the shape, and then you can do 1. Notice the connection between these two graphs. The points are just switched. Because the bases were reciprocals of each other. There's connections here. And then I draw my asymptote. Because notice there's no shifts here. This is just b to the x. Means the asymptote is 0. Oh, I'll do it in yellow. It's easier to see. And then I look at, the points on the right are closer to the asymptote. And so the right side is the side that's going to go towards the asymptote.
Wait, so what happens with that? You put the y equals 0 on?
No, it doesn't. Except I like to put it on the side that's closer as a reminder to myself that's the side that has the asymptote. Because the other side, it's not approaching the asymptote there. Right? It's just a visual reminder for me. It doesn't actually matter where you label it. Okay, I'm going to write my end behavior statement. X arrow negative infinity, y arrow 0. That's what gives me the HA of 0. Right? Unit 6, we had a hard time connecting that statement. Here it is again. X arrow positive infinity, y arrow 0. That's where the HA comes from. It's from the end behavior statement. The plugging in infinity and what would happen.
So anytime that b is like a fraction,
Well, okay, a fraction less than 1. Because 3 halves is more. 3 halves would be over here. Okay. All right, we have 4 minutes. I think we're going to do one graph. And then we'll end. Okay. So you can turn your paper. That's where I'm at. You can put your 3 graphs in there. Okay, we're only going to use maybe one of them today, and we'll just continue with them next class. Okay? So you have graphs. If you want to cut them up and separate them, that's fine. This just makes it easier not to. Okay. You need a little bit of writing space. Not too much, but a little bit. All right, so you can go ahead and get your graphs in there. There's tape up here. If you've got glue, that's fine. Scissors. There you go. Okay, tape.
Not the one the creeper.
I accidentally said something listening about something like if you got your I was like, oh my god, you accidentally he owns this school. And he was like, oh my god, like almost like 500 feet ahead of me. He turned around and goes, what? You didn't know that. Oh my god.
I felt bad.
You can ask my sister. My sister was like,
You could act like freaking sister.
like, she was laughing. She's like, Rest of you dead.
No, honestly,
Because I talk loud.
yeah, like she would actually do that.
Anybody else need? Okay, a couple more over here coming in.
Yeah, you get dry.
Okay, that's going to be class today, guys, so make sure your graphs are taped in. We will start with transformations tomorrow. Your homework, make sure that you are going through worksheet 2 evens. I know there's stuff in there that you need to look at, okay? And then your SOL quizzes, make sure you are ready and done with those for tomorrow.